So compound interest is a specific application of this model where we are taking our interest and we're earning interest on the interest. So instead of just earning a straight 4% of our initial investment every year, so if we invested $1,000, 4% of that would be $40, so we would just get $40 a year. Simple. Compound interest says, well, the first year we get $40, but then the next year we get $40 plus 4% of that $40. And then the next year we're getting interest on the interest on the interest, and it keeps building on itself. We're earning interest not only on our initial investment, but also on the interest. So it's kind of a sweet deal. And it is exponential because it's growing by multiplying by that 4% over and over and over again. So if it's annually, if the compound interest is annual or yearly, can't spell right now for some reason. Annual, yeah, it's two N's. Annual or yearly, then we can just use this. But if it is, say, monthly or weekly, it's a little different. So how this works, if you get compound interest monthly, then what they do is they say, okay, let's say I have 5% APR. So that's my annual percentage rate. So that's how much per year I'm going to earn in interest. But then they say compounded monthly. Okay, so this means that actually, instead of giving me that 5% once a year at the end of the year, they're going to break it into pieces. So every month I'm going to get a piece of that 5%, and then it grows a lot faster that way. So what we would have to do is take my 5% and divide it by 12, because there's 12 months in a year. But then I'm going to get it 12 times during the year. So I'm going to get 1/12 of my 5% 12 times a year instead of getting just my 5% once a year. So how this equation works is we still have our initial amount, 1 plus, we're taking our rate and dividing it into 12 pieces, and then we're going to do it 12 times each year. Again, so we're taking our rate, our 5% or whatever that rate is, and breaking it into 12 pieces for the 12 months of the year, but then I get that interest 12 times per year. So instead of just getting it once a year, I get it 12 times each year. So the formula for this is A times 1 plus R over N to the NT, where N and N, both of these represent the number of times per year that it's compounded. Okay, so this is where we get to learn some vocabulary. So if it is semi-annually, that means 2 times a year. So our number for N would be 2. If it's quarterly, A lot of things in finance are quarterly. Taxes for businesses are done quarterly. So a lot of things end up getting done quarterly. So that would be 4 times a year because there's 4 quarters in a year. If it's monthly, 12 months in a year. If it's weekly, there's 56 weeks in a year. If it's daily, there's 365 days in a year. I've seen problems where it's hourly or by minute or whatever, but we're just going to stick with these, okay? So let's do an example. Let's say that I go back to that same situation in my last one. So I have my $1,000 and I am going to invest it at 5%. And before we just did it, it was compounded once a year. Well, now let's say it's compounded monthly. So again, there's 12 months in a year, right? January, February, March, 12 months in a year. So I'm going to write my equation. Y equals my $1,000 times 1 plus my 0.05% divided by 12 to the 12t. Oh, I forgot. In our last example, we used 4% interest in the last video. So this is going to be 0.04 because I want to be able to compare, see how much of a difference compounding it monthly versus annually makes. Okay. So again, I got to do order of operations. I have parentheses. I have to do what's inside the parentheses first. I'm going to divide first. So on my calculator, I'm going to have my 0.04 divided by 12. So this is 0.003 repeating to the 12t. Oh, and I think we said last time 10 years, right? So I can take the t out and put 10 here. All right. So now I'm going to take that number, and again, I'm just going to leave things in the calculator and keep going so that I don't have to keep retyping these long decimals, and I'm going to do my very best not to round until the very end. So I'm going to take this, and I'm just going to hit +1, and again, if I just hit the plus, then it automatically brings the answer down. So now I have 1,000 times 1.0033 repeating to the, I can do this in my head. 12 times 10 is 120. I'm going to go ahead and do that now so I don't have to worry about doing it on the calculator. Now I'm going to take this number, my answer, and raise it to the 120th power. So that's how many over 10 years, 12 times a year, I'm getting interest. So I'm going to end up getting 120 small interest payments of only 0.3% each time. But because it's so many times, it ends up being a bigger amount. Okay, so here's my new B value, my interest. And then I'm going to take that times my 1,000. So this is 1,000, I forgot to write it, times 1.49 dot 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 dot. Okay, and so now I get $1,490.83. All right, and I think before we said $1,480. So it's just by changing, everything else is the same, but just by changing from compounding it once a year to 12 times a year, I got an extra a little over $10. That's pretty nice. And you could probably imagine that if I started with a bigger amount, or if this was bigger, it would make an even bigger difference over the course of time.